This year was really hot, but it was also really cold. And if you felt that it was maybe hotter or cooler this year compared to last year, you'd be correct. Extreme weather events, as well as extreme temperatures, were observed this year. And it may be that climate change is the reason and cause for this. All joking aside, climate change is impacting people's lives all over the world. It's destroying businesses, it's destroying homes, and it's posing a real hazard to human health and existence. This picture is from the UK just this year, and scientists say it's only going to get worse if we don't do anything about it now. Some of us may have heard about emission reduction goals, such as reaching net zero by 2050. And if not that, maybe more of you have heard about Greta Thunberg on the news. And the point really can't be made clearer. We need to reduce our emissions and live sustainably. Right now, we need to reduce the amount of carbon dioxide in the atmosphere.
There's currently tons of CO2 in the atmosphere. Just to give you an idea of how much we emit, on the left is a white dot, which represents the trillions of stars in the universe. And on the right, that great big ball represents the CO2 molecules released every day. So what can be done? Our number one priority is to reduce the amount of carbon dioxide we release into the atmosphere. We can do this by reducing our dependency on fossil fuels, by using renewable power. In the UK, we normally use wind power, but elsewhere, solar and geothermal energy are used. We, as individuals, also have a part to play. And there are many things we can do, such as reducing consumption, cycling to work, and eating less meat. But with the scale of the problem being as large as it is, individuals can only do so much at home. Is there anything else we can do to help fight climate change?
I'm glad you asked, Beth. One thing that we can do is to capture the carbon dioxide at its source. This is where carbon dioxide is in its highest concentrations. And we can use carefully designed materials that act a little bit like sponges, which catch the carbon dioxide. Once we've captured the carbon dioxide, we need to work out a way to transport it to where it needs to go. This can be done using pipes, big trucks, or ships, just like the ones in this image. The important question to answer here is how do we measure the amount of carbon dioxide that we're transporting? Because we're going to be transporting a lot through these transportation networks. I'm sure many of us have had to hunt for the gas meter at home when it's time to take the readings. The ones used to measure carbon dioxide are not much different. One of the things we need is a way to validate the existing meters to make sure that they're accurate enough to do the job.
So we've captured and transported the CO2. Now what do we do with it? Well, one exciting thing we can do is to use our chemistry skills. Using carbon dioxide and lots of chemistry, we can make useful products such as plastics, building materials like concrete, or fuels for cars. You might be thinking, wait, we're making fuels for cars? Isn't that the problem we're trying to solve? And you'd be right. But by using this fuel instead of a newly dug up fossil fuel, we create a circular economy, a little like the water cycle, where nothing new is added or taken away. We can also store carbon dioxide in underground rocks. You can see in this picture that we pump CO2 into deep reservoirs, where it is trapped. We take these funny looking samples from the rocks that look a bit like Pringle cans and study them in labs.
And the main question that we're trying to answer here is, will the carbon dioxide stay trapped? Researchers use imaging techniques to look really closely at the rock structure to answer this question. By studying the rock, we can work out how carbon dioxide interacts with it. We can also increase the amount of carbon dioxide that these rocks store safely. Our atmosphere is a little bit like a bathtub. The open tap shows carbon dioxide emissions entering our atmosphere, filling it up just like it would a bath. Today we've talked about ways to close this tap, but we can never fully close it. At some point we're going to need to pull the plug, removing carbon dioxide emissions that are already in the atmosphere. And that's where negative emission technologies come in. These are technologies that simply remove carbon dioxide directly from the atmosphere, and they don't release them back again. And the idea here is that these technologies are carefully designed to remove more carbon dioxide than they emit.
There are several proposed negative emission technologies. We can use trees, the ocean rocks and minerals, as well as specialised machines that remove CO2 from the air. Each of these have their own pros and cons, and we need to consider energy, the space it takes, and the financial cost. Some of you might be wondering why it's so difficult to remove CO2 before it gets into the atmosphere. It's not as easy as capturing it in a big net. It's really difficult because carbon dioxide is so similar to all its surrounding molecules. We have to find very special materials that capture carbon dioxide, and only carbon dioxide. Finding these special materials is difficult because there's so many trillions of possibilities. We need to use supercomputers to go through the many options. Then we can test each material individually to work out which ones are best for capturing CO2. A greener future is in our grasp. These technologies that we talked about today have the ability to halt climate change and possibly even reverse it. We still have some research to do, but if we use these technologies, and we all do our bit at home, we have a real chance of tackling climate change.
And we just have to do it. This is a time-sensitive problem. As we mentioned earlier, we're already experiencing the impact of climate change. We know what technologies we need to use. We know what we can do individually to help. We just have to do it, and we have to do it now.